Hello and welcome to Lesson 8.3, Factors of Counting Numbers. Today you'll be able to find factors of counting numbers. You're going to need a copy of the Multiplication and Divisions Facts table, as well as Math Journal page 259. Let's start with a warm-up. Solve these facts on the back of your Math Journal page or a separate sheet of paper. Pause the video to give yourself time to solve. Remember, the more warmed up you are, the easier the rest of math will be. Here are the answers to the warm-up. Again, you can pause the video and check your answers. How'd you do? I bet you got most of them right. Nice work. Now it's time for today's math message. Joanna packed 16 bottles of juice into cartons. How could she pack the bottles so that each carton has an equal number of bottles with none left over? Show your thinking using pictures or arrays. Then, write a number model for each of your representations. Again, please pause the video to allow yourself time to solve. Here are some possible number models that you might have come up with. 1 times 16, 2 times 8, 8 times 2, 4 times 4, or 16 times 1. The example shown here would fit the number model 2 times 8 equals 16. There are 2 boxes, or 2 rectangles, and 8 bottles in each of the boxes, which represents 2 times 8. Here's our key vocabulary word for the day: factor pairs. Factor pairs are factors we can multiply to get the same product. Here are the factor pairs for 16 from the math message. 16 is the target number that we were trying to reach, but it's also the product. Remember, anytime you multiply two factors together, the total is called a product. The factor pairs are the two numbers that you're multiplying together. So 1 times 16 is a factor pair for 16. 2 times 8 is also a factor pair for 16. 4 times 4 is another factor pair for 16, as well as the turnaround facts from above. Here's another list of factor pairs for 30. Again, 30 is the target number or the product, and the factors being multiplied together are the factor pairs. So 1 times 30 is a factor pair for 30. 2 times 15 is a factor pair for 30, and so on. Can you make a factor pair for 5 and 16? If 16 were your target number, then no. You can't make 5 equal groups of something to get a total of 16 without having any left over. In other words, 5 times any other number will never give you 16, when working with whole numbers in 3rd grade at least. How could factor pairs for 16 help you package the bottles? Again, this goes back to the math message we were doing. If you know the factors of 16, you can make equal cartons of 16 bottles. So again, here are all our factor pairs. You could have 1 box of 16 bottles, 2 boxes of 8 bottles, 4 boxes of 4 bottles, 8 boxes of 2 bottles, or 16 boxes with 1 bottle in each box. How could you make 10 bottles of juice into cartons so that each carton has an equal number of bottles with none left over? The first thing I'd like you to do is create a factor pair list. On your paper, try to write down the factor pairs that you can multiply together to get to 10, your target number. You might want to start with just 1. 1 times 10 equals 10. 2. 2 times 5 equals 10. 3, no, 3 times 3 is 9, so we can't, it's not a factor pair. 4, no. 5. Now we're on our turnaround rules. 5 times 2 is 10, which means also 10 times 1 will give you 10. This is your factor pair list. Pick one of the factor pairs that we've jotted down and draw a model of one of the factor pairs to represent the problem. Again, this could use circles, pictures, counters, some way to visually represent one of the number models. I'm going to start with 2 times 5. So I need 2 groups, and each group will have 5 in it. This might look like an array, or you might have actually drawn the rectangles around them to represent the cartons. Please take out your multiplication and divisions facts table. With your finger, find 2 on the top row. We're going to skip count down until we reach the number 10. Ready? 2, 4, 6, 8, 10. What factor times 2 gives a product of 10? So 2 is one factor. The target number is 10. 2 times what factor gives you 10? That's right, 5. Let's draw a triangle connecting these 3 numbers. So I have from 5 to 2, back down to 10, over to 5. Please make sure you're using a pencil. Why do you think we drew a triangle to connect these 3 numbers? I thought I heard someone say it. Remember, this is like a fact family. If I changed the way that our triangle looked, we have our 2 and our 5 as our factor pairs, and 10 at the top as our target number or the product. See if you can find the same fact family in another place. So remember, the fact family is 2, 5, and 10. So we've already used the 5 over here. We've already used the 2 over here. Think about the turnaround rule. You should have found the 5, skip counted to 10, 5, 10. 5 times the factor 2 gives you 10. There's your other fact triangle for the same fact family. Go ahead and draw the triangle with your pencil. You think this fact family is on our facts table twice. Why do we have 2 times 5 is 10, and then we just found 5 times 2 is 10. Right, Because of the turnaround rule, we have two fact triangles or fact families that look the same for this product of 10. Go ahead and erase your boards. Next, I want you to see patterns on our multiplication and division facts table. Let's start with our 2's. What patterns do you notice for all the products of 2? Remember, these are our factors and these are our factors. The first row and first column are our factors that make our factor pairs, and all of the numbers in the middle are your products. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. These are all products of 2. You should notice that all of these numbers can be divided into 2 groups with no leftovers. Also, all of these multiples of 2, remember when you skip count, those will become multiples, are even numbers. Let's take a look at the multiples of 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. What patterns do you notice here? Right, they all end in 0. All of these numbers are multiples of 10, and all products can make equal groups of 10. For example, 40 would be 4 equal groups of 10. See if you can find the patterns for products of 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. You might notice that all of these products have a 5 or a 0 in the ones place. All of these numbers are multiples of 5, and the products can make equal groups of 5. 50 would be 10 equal groups of 5. 25 would be 5 equal groups of 5. You practice using the multiplication or division fact table. Find factor pairs for 30. You can make a list or make triangles as you need. Please pause this video to give yourself time to do that. Factor pairs. 3 times 10 is 30, or 10 times 3 is 30. 6 times 5 is 30, and 5 times 6 is 30. Now, can 30 juice boxes be put into 2 equal cartons? Yes, they can. 30 is an even number, so I know it's divisible by 2. Even though 30 is not on this facts table, I know I can make 2 equal groups from when we looked at our patterns of 2. Always keep these patterns in mind because our factor pairs only go up to 10 on this table. Is 11 on the fact table? Our factor pairs only go up to 10. 10, 12, 9, 12. I can't find a single 11. How about you? Does that mean it doesn't have any factor pairs? Of course not. Every product, I should say, has at least 2 product pairs. Every product has a product pair with 1 and itself, plus the turnaround rule applies. So the factor pair for 11 would be 1 times itself, or 11 times 1. Please try page 259 now on your own. Good luck!